that we can gain something. Okay, whatever we learn through puzzles or some riddles and whatever, we can learn something out of it. So in this particular scenario, this 5-block puzzle, this one basically you need to tell which blocks contain the number you chose in between 1 and 31. And if you tell me the block numbers, I can tell the number, which number you chose. Okay, this is basically dealt with younger kids, like usually third grade to 5th grade or 6th grade, something like that. But we can learn some binary number system, how it works, and how to manipulate numbers from decimal and this system to binary system, and from binary system to hexadecimal system, and so many other things. So these are very, very interesting topics. But rather than directly educating in binary system and all that, usually I choose this pattern. Here actually play something and we get some knowledge out of it. So that is the idea. So if you currently, ask you to find, choose a number and tell me which blocks contain that particular number. So you already said 1, 3, 4, and 5. Is that correct?
Yeah, just a minute, sir. Sir, 1,
Yeah.
3, 4, and 5. Yes, my number is in
1, 3, 4, and 5. Okay. 29.
Yes, sir.
Is that right?
Yes,
Yeah.
sir, correct.
Yeah. So, you may wonder, if you already know what I did, it's easy. But if you don't know, you think it's something interesting, right? So any one of you, actually, any one of the kids joined in this group can volunteer. If you raise your hand and ask the question, unmute and ask the question, which blocks contains the number you chose, I'm going to tell the number. Let's do 3 more, and then I am going to explain how it works. You can unmute any one of you and ask.
Hello.
Okay. Yeah.
Can you hear me?
Yeah, sure.
Okay. So my number is in the blocks 1, 2, and 3.
1, 2, and 3. It's 7. Is that right?
Yes, sir.
Okay. What about another person can ask now? Okay, Alexander. Sorry, can you repeat?
My number is in 1, 2, 4. 1, 2, and 4.
1, 2, and 4. Okay, it's 11. Is that right?
Yes.
Okay. Okay, another person can ask.
My number is between 4 and 5.
Only in 4 and 5, right?
Yes.
It's 24. 24. Is that right?
No, it's 26.
26? Okay, it should be there in another one. Second one also is there, right? So you missed it. Okay, another question. Another one.
So my number is in 1 and 2.
1 and 2? Oh, 3. Is that right?
Correct, sir.
Okay. So let's see how it works. Okay. Then probably you feel very comfortable. You can draw these numbers. Actually, you can draw these puzzle blocks by yourself by the end of this session. Okay. Let me clear this. What happened? My PowerPoint. Oh, sorry. Again, I'm sharing it. Okay. Here I see how to frame it. Okay. Prior to that, in this particular case, we have 5 blocks, right? So I'll tell the solution how we do that. Okay. Suppose if you tell one of you told like, the number you chose is in one first and second block, right? First block and second block. So what you need to do is you need to concentrate on the top left corner number. Okay, 1 in this case, 2 in this case, 4 in this case, and 8 in this case, and then 16 in this case. Okay, just focus on that. And then if the number is there only in first and second blocks, just you need to add these top left corner numbers. So 2 plus 1 is 3. Okay, if you see these blocks, 3 is there only in these 2 blocks. You cannot find 3 in any other blocks. Okay, another person asked like, it's there in first block, second block, and then fourth block, first, second, and fourth. Then you need to add. Can someone tell what you get? First, second, and fourth.
You get 11.
11, right? Yeah, you get 11. So simply add 8 plus 2 plus 1. Okay. Suppose if someone says, what is the number if it is there in second and fifth block? Only second and fifth.
Second and fifth block, the number is 18.
18.
18. Yes, you get 18 like that. Okay, that is easy, right? Now you can solve. You can play with your friends with this. Okay, now let me show you how to construct this. Okay. See, I wrote all the 5 blocks, and we are going to fill in those blocks. Okay, just to focus on this. Don't try to write anything at the moment, and I can tell you like how to do it. It's very easy. Okay, if you see the numbers 1, 2, 4, 8, and 16, what is the significance of those numbers? How they are related? Can anyone tell?
I think 1 times
1
2 times
plus
1
1 is
equals
equal
2. 2 times 2 equals 4.
to doubling.
4 times 2 equals 8. And 8 times 2 is 16.
Yes,
So-
very
Doubling,
good.
sir. Doubling.
Yeah, doubling. Yes, that is very good. Doubling. You are doing doubling, and you got all these things, all these numbers. Okay, we say actually these are powers of 2. Okay, 2 to the power 0. How many of you know this? I think 7th graders might know about this, right? So if you take
0 times 2.
what?
So you get only 2.
Yeah, 2 power 0 is 1, and 2 power 1 is 2. And then if you take 2 square is 4. Okay, you can write it here like 2 power 0 equal to 1, and 2 power 1 equal to 2. 2 square equal to 4, and 2 cube equal to 8, and 2 power 4 equal to 16. So that is what we used. Okay, in this case, actually, I took 5 blocks for convenience. Okay, the puzzle should not be so easy and it should not be so difficult. Suppose if I take another block, then you are going to have more numbers
Well,
on
yes.
this. Okay, now currently we have 16 numbers in each block.
Yes.
But if you take, sixth block also, then you are going to have more numbers, which is a little like confusing. And if you take only 4 of them, then you are having very less number, like not 16, you get less numbers. So that means basically it's going to be very, very easy. So that's why I chose this 5 by 5. Okay, 5 blocks. Okay, now let me show you next step. Okay, we have 1, 2, 4, 8, and 16. These are the top left corner numbers we wrote. And then if you want 3, how do you get 3? We have already 1 and 2, okay, in those blocks. If you want 3, how do you get 3? When you add 2 plus 1, you get 3, right? I need an answer. I mean, did you understand that part?
Yes, sir.
Yes.
Yeah, so you're supposed to have 3 here and 3 here. Okay. And then suppose if you want 4, it's already there here, right? So you need not worry about it. If you want 5, how do you get 5? How do you get 5 with the corner numbers?
4
You have
plus
4
1.
here.
4 plus
4
1.
plus 1. Yeah. So in this block, you need to write 5. And here also you need to write 5. Do you agree? 4 plus 1 is 5. So we need to write 5 in these. What about 6? How do you get 6?
2 and 4.
4 plus 2. 4 plus
5
2.
plus
No. Actually, you need to take only top left corner numbers. Okay.
2
So
plus
4 plus 2. Yeah, 4 plus 2
4
is
plus
going to be
2,
6.
6.
So you get 6 here and 6 here. Is that clear so far?
Yes.
Yeah. Now, how do you get 7? Can anyone tell? How do you get 7?
1 plus 2 plus 4.
1
1 plus 2
2
plus 4.
plus
Actually, you need
4.
to, yeah, 4 plus 2, 6 plus 1, 7. So you need to write 7 in all the blocks, all the 3 blocks here. 7. Does that make sense? That's easy, right? So far, it's easy. Okay, if you want 8, we already have 8 here in this block. So if you want 9, 8 plus 1, 9. So you need to put 9 here and 9 here.
8 plus 1.
Yeah, 8 plus 1 is 9. What about 10? 8 plus 2, right? You need to write 10 here, 10 here. And what about 11?
8 plus 2 plus 1.
8 plus 2 plus 1. You need to write 11 in all the 3. Here, here, and here. Is that clear? So this is how we need to fill the blocks. And if you want another block, for example, if you want 6th block also, then you need to have, what is the corner number? Can someone tell? What do you get here?
24.
No. You're multiplying by 2. 32. See here, actually 1 times 2 is 2. 2 times 2, 4. 4 times 2 is, yeah, you get 32. 16 times 2, 32. So that is what you get. If you want another one, what do you get?
64.
64.
That's
Like that.
128.
Yeah, 128. You can increase so on. Like you get more number of cards if you do that way.
246.
No, that is 256. Okay, yeah, let's stop it there. Okay, that part is clear now. Okay, let me show you next steps. Actually, this is how it goes. Yeah, if you see here, next step is I told you 3 how you get it. Okay, so you can have a block like only 2 blocks with only 2 numbers like this. That is also, you can, if you ask a person to tell any number in between 1 and 3, including them, then if you say 1, it's there only in first block, first card. And if someone says like 2, then you can say only second block. If someone says 3, you can say it's there in both the cards, right? Like that. So we can extend it like this is how we can extend it. If you take this one, this is another 3 by 3 block. Okay, it looks like this. We have 3 cards and we can ask them to choose a number from 1 to 7. 1 to 7. Okay, suppose if you selected 7, if they say, okay, that number is there in all the 3 cards, then you can add 4 plus 2 plus 1, which is 7. So 7 is there in all 3 cards. Is that clear to everyone? Okay, good. Let's go further. Okay, we can add our numbers like that. So this is how you get. And then this is what we got, 5 by 5. Okay, 5 block puzzle. So we have 5 blocks. This is what I showed you in the beginning. So now you can prepare your cards at home and you can play with your friends. Okay, so far this is a game, right? Now let me show you how we can relate this to binary numbers. How many of you know binary numbers? Binary numbers.
Sir, I only know that binary numbers is the computer's language, which transforms everything into 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 1, and stuff like that.
Wonderful. Yes, that's a good answer. Actually, that's correct. So in computers, we use binary numbers, and then we can use octal numbers. Okay, and we use hexadecimal numbers. These things actually all are 2 powers. Octal means 8 digits. We use only 8 digits. Okay, hexadecimal means we use only 16 digits. Okay, I'll explain you those things a little bit later. So the decimal system we all know, right? We use 10 digits, starting from 0 up to 9. We use 10 numbers, 10 digits. Okay, using those 10 digits, we can frame any number, any decimal number. Okay, the same thing can be shown in binary number as a binary number. But if you see binary number, the length is going to be more. Okay, suppose if you take 7, for example. Okay, if you take 7, let me show you this. If you take 7, okay, decimal system, basically we write base 10 like that. Okay, which is equal to 1, 1, 1 base 2. This is the binary system. Okay, can you relate this with that, with those blocks I showed you? See here, for 7 we have 1, 1, 1. Okay, if you take 1, 1, 1, this is equal to 7 in decimal system. Okay, 1, 1, 1 means basically if you take the those 5 blocks. Okay, one block is having corner number 1, the other block is having corner number 2, and then third block is having corner number 4. So when you add 4 plus 2 plus 1, you get 7. So 7 is there in all the cards, isn't it? So because it's having 7 in all the 3 cards, we wrote 1, 1, 1. If it is there, we write 1. If it is not there, we write 0. Suppose if you take 5, can you tell what number you are going to get in binary? Anyone?
I don't know, 1, 1, 1, 1 something.
No, 1, 0, 1. See, 4, for getting 5, you need to add 4 plus 1, right? Here we have 4, here you have 1. So you need to put 1 and 1 here because that number is there. And here you need to put 0. So you get 1, 0, 1 base 2. Is that clear? So like
Yes.
that we can convert decimal number into binary number. Okay, I'll give you some more examples, and then probably you can understand much better. Our goal is to tell a binary number when I give you a decimal number. That is our goal by the end of this session. Okay, let me clear this. Okay, let's go with the next slide. Okay, I gave lots of information here, but we'll skip it. As I said, the octal number, actually we use numbers 0 to 7. Okay, if it is hexadecimal number, we use numbers, 16 numbers, 16 digits we use. What are the 16 digits? We know only 10 digits, right? 0 to 9. We know only 0 to 9, we know. And then we use A, B, C, D, E, F. Those 6 alphabets also we use as digits, okay, in hexadecimal system. We are going to learn that later. Now coming to this, how to convert a decimal number into binary number. Okay, let's take 25. How to convert this into binary number? First we need to divide this by 2. Okay, then you are going to get 12. What do you call that? 12 quotient, right? And then 1 remainder. Now again divide that by 2. You get 6 and 0. 0 remainder. Okay, and again divide that by 2. You get 3, 0. And again divide that by 2. You get 2 ones are 2, and then 1 remainder. Okay, 1 and 1. Okay, and again divide that by 2. You get 0 and 1. Okay, what here we are doing is we are dividing this 25. Okay, let me explain this. we are dividing this 25 by 2. We are getting 12, and then remainder 1. And then we are dividing this by 2, and you are getting 6 and remainder 0. And when you are dividing this 6 by 2, you are getting 3 and remainder 0. Like that we are getting. Okay. Now, our, the binary number, if you take 25 base 10, okay, the decimal number 25 is equal to, we need to write the numbers from bottom to top like this. See, 1, 1, 0, 0, 1. So this is the binary number. Okay, this is a traditional way how we do it. Okay, let me tell you how to do it mentally. That is our next step. Okay, so this is how I need to convert. Now coming to okay, suppose if you want to convert 52 into binary number, can you try this? 52. You need to do the same way, like okay, let me show you this. 52 you can do in multiple ways, but here actually let's take 52, divide that by 2, you get 26, remainder 0, and again divide this by 2, you get 13, remainder 0, and again divide this by 2, you get 2, 6, 12. I think someone is drawing it, so okay, 16 and remainder 1, and then again divide this by 2, you get 3 and remainder 0, and then if you divide this by 2, you get 1 and remainder 1, and then when you divide this by 2, you get 0, so, and then 1. This is what you got. Now you can write 52 base 10 is equal to, you can write 1, 1, 0, 1. Let's write it 1, 1, 0, 1, and then you take 2 zeros. Okay, and base. Is that clear to everyone? How we are doing it?
Yes, sir.
Okay, wonderfully good. So now here actually what we do is basically in decimal numbers, suppose if you have a number like 3, 4, 5, 6, 7, 8, something like that. So how do we tell the place values? This is ones or units, and then you have tens, and then hundreds, thousands, and 10,000s. It's like that. I mean, the place value increases, right? Is that, do you know, every one of you know that? Yeah.
Yes.
So here units, tens, hundreds, thousands, 10,000s, and then 1 lakh, or sometimes, in US and all, they say, what do you call that? 100,000, something like that, right? So whichever way you use in decimal system, that is, those are the place values. But in binary system, we use the same way, like ones are units, and then twos, fours, eights, 16s, 32s, like that we need to write. Okay, did you get it?
Yes.
Okay, now let me tell you how to do this in a different way. Okay, so we chose 52. Okay, we need to know these 2 powers. Okay, 1, 2, 4, we already know from the block puzzle, right? The corner numbers 1, 2, 4, 8, 16, 32. These numbers we already know. So 52, when you take, what is the number which is smaller than 52 in this list? Smaller than 52 and greater number. Can someone tell? Here we have
32.
32. Yes, 32 is the number we need to choose, and we need to subtract 32 from this. Okay, 32, because 64 is greater than 52. And the number just below 52 is 32. 2 powers. Okay, now we subtract 32 from this. Okay, 32, when you subtract, you get 20. And then in 20, which is the number, smaller, I mean, 2 powers, you need to find a 2 power, which is smaller than this.
16.
16, right? You need to subtract 16 here. So your remainder is 4. Now
And then 4.
Only 4. Yeah, when you do 4, you get 0. So reminder 0. Whenever you get reminder 0, now we need to write the binary number. Okay, we can do that in. I'll show you how to do it. Okay, first we have 32. Okay, 32. Here you need to put 1. Okay, so that one actually we'll write it here. And then 16. We have a 16 also here, right? So put another 1. Okay, and then do we have any 8s? No, right? So you need to put a 0. And what about 4s? We have 1 4 here, right? So we need to put 1. And then 2 and 1. We don't have any 2 and 1s here, right? So you need to put 2 zeros. So this is your binary number. Is that interesting? How we did it? Okay. Now actually, if I ask you, if I give you a number, say 15, can you tell me what is the binary number for this? 15 means basically you need to see these numbers list. Okay. 16 is greater, right? So you need to start with 8. Okay. So right here 15, and you need to subtract 8. You are getting 7. Isn't it? Now we already used 8. Now next number is 4. So subtract 4. You get 3. And then you have 2. Subtract 2. You are left with 1. And then you have 1. So write 1. And the remainder is 0. So now we have 1, 2, 4, and 8, the corner numbers. So what is the equivalent binary number? Need to put 4 ones.
4 1.
Got it?
Yes.
Okay, let's play that game. Like, I'll ask you to, I'll give you a number, decimal number. You need to tell what is the binary number. You can do on your paper. Actually, you can solve it. Okay, I'm going to give 12. Can you tell what is the binary number?
So we have answers coming in the chat box.
Oh, okay. Can you just
Yeah, it's 1100.
1100 is
one.
correct.
And someone has written 111111111. I'm not sure.
No. 1100. This
So
is
most of them are telling 1100.
Yeah. So 1100. How did you get it? So basically, if you take 12, the closest, 2 power, which is smaller than 12, is 8. Yeah, that's correct. Whoever is drawing there, but don't do that. Okay. Yeah, here you have 8.
So actually, you can stop the annotations in your
Yeah. Right. I think anyway, we are actually coming
We're
to
almost at the end, so it's okay.
Yeah. 12 minus 8 is 4, and then we have 4 here, right? So you need to subtract 4. You got remainder 0. So we have 8 and 4. So you need to put 1 1 and then 0 0. So this is your binary. Okay, let's do another one. Okay, suppose if I give 10, what is your binary number? 10 base 10. But 10.
Zero, 104.
Yes, 1010. That's correct. This is what you get. Okay, I think we got what we are looking for. Okay, let me show you next one. Okay, I gave the same thing. Okay, and now I think okay, let's go to the next thing. Oh, come on. I think who is doing that?
Can everybody stop annotating, please? Let the teacher
Oh,
do
okay.
work. Thank you.
Okay, I'm done with this. So let's see how to convert. I gave you all this information here. So converting from binary to octal number. Okay, this is what actually we can do it very quickly. Let me explain that rather than reading all this stuff. Okay, let me take a blank page here. See. Okay. Suppose if you take any number, say 1 0 1 0 1 1, something like that. If you have a number is binary, if you want to convert it into octal number to the base 8, okay, how do we do that? Basically, many times actually traditional way, you convert this into decimal number and then divide that by 8. As I said earlier, suppose if you convert this into decimal number, you get 1 plus 2 3, and then this is 0 and 8 11 11, and then 32 33 43, you get 40. Okay, the value is 43. Now this is base 10. You need to divide this by 8. So 8 5s are 40, and then remainder 3. Now again divide this by 8, you get 8 zeros and then 5. So 5 3 is the octal number here. 5 3, that is what you get. So this is the traditional way, but we need not do all that. When you know the binary number, actually from right, actually you need to take 3 digits at a time. Okay, draw a line here in between. So now we have 0 1 1 on one side and 1 0 1 another side. So if you take this one and convert it into decimal number, how do you do that? You write 1 2 and then this is 4. So 1 plus 2, you get 3. So that 3 we already got it here. And then if you take the left part, you have 1 1s 2s and then 4s. 4 plus 1 is 5. So that is what we got. So you need not do convert it into decimal and then divide by 8 again. It's not needed. Actually, you need to split that number into three blocks like that. Okay, and then you can put you can find the value of each one of those the numbers, and then you can find the octal number. Okay, let's do another one quickly. Suppose if you have 1 0 1 1 0 0 1 1 1, something like that, you have a number. Okay, you need to convert this to octal. How do we do that? So you need to start from right. 1 2 3. After 3 you need to draw a line. Okay, and then 1 2 3. After 3 you need to draw a line. Suppose if you have only one digit here, then you can put the same digit. And if you have 2, then you need to find the value of it, okay, in decimal. So if you have 1 1 1, that means you can think 1 1s 2s and 4s. So what is the value of this? 7. You need to write 7. Okay, now if you take 1 0 0, this is 1s 2s and then 4s. 4 times 1 is 4, and these two are 0. So you can write 4. And if you take 1 0 1, you can write 1s 2s and then 4s. So this value is 5. So the binary number this is equal to 547 octal number. Okay, I'm giving you one more question, and probably you can solve and tell me the answer. Okay, 1 1 0 0 1. Okay, this is the number I gave. Can you tell me the octal value for this?
We have 31 as an answer from most of the participants.
Okay, 31, that is correct. So here if you
We
take
have a
ones,
few more minutes. We might need to start the second session. So
okay. So yeah, I'll conclude with this. Okay, 3
thank you.
3 7. No, sorry, not 3 7. 3 31, right? 3 1. Because you have only one, these two are zeros. So how many of you liked it? So interesting, right? Yeah, you can prepare that 5-block puzzle and you can play with your friends. Okay.
I
That is
like
how
it
it-
very much.
Oh, thank you.
I like it too very much.
Yeah, thank you. Thank you. Okay, I'm done.